Long before the age of steel and steam, humanity gazed upon the ocean with a mixture of reverence and fear. To the ancient mariner, the sea was not merely water. It was a living expanse of mystery, a dark mirror reflecting both the unknown world and the fragile imagination of humankind. Legends spoke of leviathans, titanic serpents whose coils could engulf entire ships, of kraken whose limbs reached from the abyss to drag vessels beneath the waves. These were not merely tales to frighten children or entertain the court. They were metaphors for the ocean itself, vast, unknowable, and indifferent. The horizon was a thin line of sunlight separating the familiar from the eternal dark. Every voyage beyond it was a descent into uncertainty, a confrontation with an alien world cloaked in waves and shadow. By the late 17th and 18th centuries, the curiosity of natural philosophers began to pierce the veil of myth. Mariners carried sounding lines, long ropes with lead weights, down into the depths, measuring what they could of the unseen floor. In these crude measurements, the first intimations of the abyss revealed themselves. Trenches deeper than the tallest mountains, plains smoother than any desert, and waters colder than any imagination could comfortably hold. Yet for all the measurement, for all the curiosity, the ocean remained an enigma. Its surface might be charted with increasing precision, but its depths continued to mock the ambitions of those who sought to understand it. It was not until the HMS Challenger embarked on its voyage between 1872 and 1876 that the first systematic exploration of the deep truly began. Aboard this vessel, scientists, naturalists, and naval officers measured, dredged, and recorded the ocean in ways the world had never seen. Over the course of 68,000 nautical miles, they took thousands of temperature readings, dredged hundreds of samples from the seafloor, and cataloged over 4,700 species, creatures of unimaginable form and resilience, living where no sunlight penetrated, surviving in cold, crushing, and utterly alien conditions. The mere presence of life at such depths shocked the scientific world, overturning centuries of assumptions. The deep was no longer a void. It was a living, breathing frontier. Primitive though their instruments were, sounding lines, dredges, thermometers, and nets, they revealed an unsettling truth. The ocean harbored life independent of the sun. The abyss was sustained not by light, but by mechanisms the surface world could barely comprehend. Tiny organisms clinging to mineral-rich sediments, strange sponges and echinoderms adapted to pressure, and the earliest glimpses of what would later be known as abyssal gigantism suggested that life had found a way to thrive in conditions that seemed impossibly hostile. These early discoveries raised a question that would haunt oceanographers for generations. What fuels these communities in eternal darkness? How could ecosystems persist where photosynthesis is impossible, where energy must be drawn from the Earth itself rather than the sun? The HMS Challenger's voyage marked the birth of modern oceanography, not merely as a catalog of species and measurements, but as a revelation of the ocean's fundamental strangeness. For the first time, humanity glimpsed a world that was both part of our planet and yet astonishingly alien. The deep sea was not simply an extension of the surface world. It was a parallel ecosystem, shaped by extremes of pressure, temperature, and chemical gradients, governed by rules that differed from those familiar on land. It was a place where evolution had taken pathways utterly unlike those above the waves, where survival demanded adaptations that challenged the imagination, and where life itself seemed to whisper the possibility of forms and processes that humanity had never before imagined. And so, the mystery of the deep began to unfold. With each sounding line, each dredge, each painstaking measurement, a window opened onto a hidden universe. It was a universe of silence and pressure, of strange geometries and alien architectures, of life that flourished without sunlight and thrived in crushing darkness. The abyss did not merely conceal its secrets. It demanded that explorers reconceive the very limits of possibility. The ocean had become more than a frontier of geography. It had become a frontier of understanding, a profound challenge to the human imagination, and an invitation to contemplate the persistence and resilience of life in the most unforgiving environments. In that first phase of discovery, the ocean revealed its first lessons: that life does not always follow the rules laid down on land, that the surface world is only a fraction of the story, and that the abyss is both a place of alien wonder and a mirror to the ingenuity, courage, and insatiable curiosity of those who dare to explore it. It was in this moment, aboard the decks of the Challenger, that humanity first recognized the profound truth that the ocean, our planet's last great frontier, is not a void, but a living, breathing cosmos hidden beneath the waves, awaiting those who have the patience, the tools, and the courage to descend into its eternal night. For centuries, the deep sea was imagined as a barren void. Scientists and natural philosophers, limited by the tools of their time, assumed that life could not endure beyond the reach of sunlight. Beyond a few hundred meters, the darkness was thought to be absolute, the pressure unrelenting, the cold merciless. In such a world, it seemed life would be impossible. The abyss was a graveyard waiting silently for any living thing that dared descend too far, a realm where biology itself appeared to surrender. Yet, the HMS Challenger had already begun to whisper a different story. Its dredges and sounding lines revealed creatures that defied expectation. Starfish clinging to mud, translucent crustaceans drifting in eternal night. Each specimen was a revelation, a fragment of a hidden ecosystem that seemed to mock the assumptions of terrestrial science. Even as the scientific community absorbed these discoveries, the implications were only dimly understood. Life persisted where no sun penetrated, where temperatures approached freezing and the weight of the water above would crush the unadapted. As oceanographic technology progressed, the discoveries became more startling. Bioluminescence appeared in an astonishing variety of forms. Fish whose bodies glowed like liquid lanterns, jellyfish suspended like drifting chandeliers, squid with eyes the size of dinner plates, reflecting the faintest hints of starlight from above. Their shapes were grotesque and magnificent. Mouths that could engulf prey larger than themselves, bodies so transparent that their internal organs seemed to float independently in the darkness, appendages that stretched into filaments to sense the imperceptible currents around them. The deep sea was revealed not merely as a continuation of the shallow ocean, but as an alien world, an intricate labyrinth of life whose rules were unlike any seen on land or in sunlit waters. But these revelations posed an even more profound question. How could such ecosystems exist without photosynthesis, the process by which sunlight drives the energy of life? On land and in surface oceans, the sun fuels the food chain. Plants convert photons into sugar, which feeds herbivores, which in turn nourish predators. Yet in the deep, there is no sun. Energy had to arrive by other means, a principle so alien that it challenged the very foundation of biology. The answer came in the 1970s, when human technology finally breached the deepest, darkest reaches of the ocean floor. Using submersibles capable of withstanding crushing pressures, scientists discovered hydrothermal vents along mid-ocean ridges. These fissures in the Earth's crust spewed superheated water, rich with minerals and chemicals. Around them thrived entire communities of life. Giant tube worms, clams, and shrimp, living not on sunlight, but on chemical energy. Bacteria within these creatures converted hydrogen sulfide and other minerals into nutrients through chemosynthesis, a process previously thought impossible in nature's repertoire. Here, life was powered by the heat and chemistry of the planet itself, by the energy seeping from the Earth's interior rather than the light of a distant star. The discovery of these vent ecosystems sent shockwaves through the biological sciences. For the first time, it was undeniable. Life is not constrained by the rules observed on land or in sunlit seas. It can adapt to extremes, to pressures and temperatures once thought lethal. It can flourish in darkness, sustained by chemical gradients and mineral energy. It can construct entire food webs in an environment that, to the untrained eye, appears utterly inhospitable. The abyss had rewritten the textbooks. The deep-sea organisms themselves seemed to embody the poetry of survival. Tube worms, with their red plumes reaching toward invisible currents, harbor symbiotic bacteria that convert vent chemicals into nourishment. Giant clams and mussels similarly host bacterial partners, creating a community that thrives where traditional ecosystems could not exist. Even the smallest, microbes forming dense mats on the vent chimneys, are architects of life in this sunless world. Here, survival is a matter of chemistry and adaptation rather than sunlight and photosynthesis, a radical redefinition of the energy flows that sustain life. Moreover, the hydrothermal vent communities hinted at possibilities far beyond Earth. If life can endure in the dark, crushing depths of our oceans, could it exist elsewhere in the cosmos under similarly extreme conditions? Icy moons like Europa and Enceladus, harboring hidden oceans warmed from within by tidal forces and radiogenic heat, could potentially host ecosystems driven by chemical energy, much like the vent communities discovered on our own planet. The deep sea thus became a laboratory not only for earthly biology, but for the study of life itself, its origins, and its potential universality. The implications of these discoveries were both scientific and philosophical. The deep sea, long imagined as lifeless and empty, revealed itself as a crucible of resilience, adaptation, and ingenuity. It is a world where evolutionary processes unfold in ways we are only beginning to understand, where the familiar paradigms of predator and prey, of energy and survival, are redefined by pressure, chemical flux, and extreme isolation. Every new dive, every sample, every photograph of a bioluminescent creature suspended in infinite darkness challenges our perception of what is possible and what life requires. Even now, the hydrothermal vent ecosystems are only a glimpse into the profound complexity of the abyss. For every vent discovered, countless others remain hidden, their communities untouched by human observation, their chemical engines sustaining life in forms yet unimagined. The deep sea is not merely a frontier of geography. It is a frontier of biology, a testament to the tenacity of life, and a mirror reflecting the limits of human understanding. It asks us to reconsider our assumptions, to acknowledge that survival can take forms so strange, so alien, that our preconceptions must bend in the face of reality. In the end, the abyss teaches a lesson beyond science. It reminds us of humility, of the fragile and fleeting nature of human knowledge when confronted with the vastness of the unseen. The discovery of life in these sunless depths is more than an academic triumph. It is a revelation of possibility. It is a whisper from the dark, an echo of resilience, and a challenge to our understanding of the living world. The ocean, in its infinite darkness, holds the proof that life is not only persistent, but inventive, sculpting existence from energy and materials of the mind of a surface-bound human might never have imagined. The impossible life of the deep sea is not impossible at all. It is merely life rewritten, a testament to adaptation, evolution, and the subtle, invisible forces that allow organisms to thrive where they should not. It is a hidden symphony of survival, a world that hums in chemical chords and glows with bioluminescent light, a universe within our own planet, waiting for the patient and the daring to explore its mysteries. In the abyss, the impossible becomes reality, and the familiar rules of life are transformed by darkness, pressure, and the inexhaustible creativity of evolution. The ocean, once a featureless expanse to the naked eye, began to reveal its hidden architecture in the mid-20th century. Advances in sonar technology, echoes of sound pulses sent deep into the water and returned as signals of the hidden world, transformed the way humanity perceived the sea. Where sailors had once imagined only darkness, trenches, and undulating plains, a complex and dynamic landscape emerged. Mid-ocean ridges, the scars of tectonic motion, stretched like vast subterranean mountain ranges across the globe, rising silently from the abyss. Trenches plunged deeper than Mount Everest is tall, swallowing sound and light alike. Volcanoes and hydrothermal vents punctuated the ocean floor, releasing heat and chemicals that sustained entire ecosystems in eternal night. This new cartography of the abyss was more than a scientific triumph. It was a revelation of Earth's living heartbeat. Sonar painted an invisible topography, revealing the planet's tectonic choreography, plates colliding, diverging, and sliding past one another in slow, inexorable motion. Each ridge, trench, and fracture became not just a geographic feature, but a locus of energy shaping currents, influencing climate, and sustaining hidden biomes. The ocean floor was no longer a static emptiness. It was alive with movement, tension, and potential, a theater of forces far more ancient and powerful than any human institution. Yet the deepest truths remained elusive. To truly understand the abyss required descent, a direct encounter with the pressures, temperatures, and alien ecosystems that defied surface comprehension. The 1964 deployment of the submersible Alvin marked a turning point. For the first time, humans could descend thousands of meters, immersed in the crushing darkness, their fragile vessels protecting them from forces that would pulverize the unshielded body. Through portholes and cameras, explorers glimpsed a world previously known only through indirect measurement. Vent chimneys belching mineral-rich water, colonies of tube worms waving like silent sentinels, and communities of shrimp, crabs, and clams thriving without sunlight. The Alvin missions transformed the abstract data of sonar into a tangible, almost spiritual encounter, a recognition that life was woven into the very fabric of Earth's hidden crust. As the decades passed, technological ingenuity expanded the reach of human investigation. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, traversed the abyss, collecting high-resolution images and samples with precision unimaginable in the age of sounding lines. Satellite altimetry added another layer to this exploration. By measuring subtle variations in sea surface height, influenced by the gravity of undersea mountains and trenches, scientists began to infer the contours of the seafloor at global scales. Even without direct descent, the ocean revealed its shape, its hidden hills and valleys, as though inviting humanity to look beyond the waves and imagine the vast world beneath. Yet despite these advances, over 80% of the ocean floor remains unmapped in fine detail. For all our sonar sweeps and satellite measurements, for all the submersible dives and robotic traverses, the abyss retains vast swaths of mystery. In these uncharted regions, earthquakes jolt the crust, methane seeps bubble from the sediment, and cold water corals anchor themselves to rocky outcrops in communities both fragile and enduring. Brine pools, dense, hypersaline lakes at the ocean's bottom, shimmer with chemical extremes that challenge the limits of known biology. Each feature represents both a physical anomaly and a potential biological frontier, a place where life, if it exists, may be unlike anything known. Extremophiles, organisms adapted to survive under crushing pressure, near freezing temperatures, and chemical gradients lethal to most surface life, hint at the richness of these unexplored realms. The mapping of the abyss also revealed temporal patterns. Hydrothermal vents, once assumed to be static, were seen to pulse and shift over years. Underwater volcanoes erupted in silence, their flows sculpting new terrain while triggering shifts in local ecosystems. Subduction zones, where one tectonic plate slides beneath another, generate earthquakes that ripple through the mantle and manifest in the hidden ocean. Each mapped trench and ridge thus represents not merely a static structure, but a theater of ongoing planetary activity, a dynamic system shaping life and geology alike. The more we map, the more the abyss asserts its complexity. Surface oceans, with their waves and tides, are but a thin skin over a deeper, more intricate body. The ocean floor, once assumed monotonous and inert, is in fact a palimpsest of geological processes, chemical reactions, and biological ingenuity. Cold water corals thrive in near darkness. Brine pools harbor microbial communities adapted to high salinity, and methane seeps sustain chemosynthetic life. Evidence that the abyss is a mosaic of microcosms, each governed by its own rules, yet interconnected in subtle ways. Exploration also revealed patterns of bioluminescence and translucence, extensions of survival strategies that sonar and altimetry could never detect. Deep-sea organisms employ light as a language, as camouflage, as a lure, illuminating the unseen with ephemeral, ghostly signals. In this way, mapping the abyss is never solely a matter of geography. It is also an inquiry into life itself. The physical contours are inseparable from the living systems they host, and the deeper we probe, the more intricate the interplay becomes between environment, energy, and adaptation. Despite our best technology, much remains unknowable. The vast expanses of the abyss hold not only undiscovered species, but also hidden chemical processes, unrecorded geological events, and patterns of life that may redefine the limits of biology. Every new map, every submersible dive, every satellite altimetry reading exposes both knowledge and ignorance. We see more clearly, yet the scale of the unknown grows in proportion to our understanding. The ocean, in this sense, is less a static frontier than a living enigma, a constant reminder that the pursuit of knowledge is an exploration of both external and internal worlds. Ultimately, the mapping of the abyss is an act of translation. From sound waves to topographic maps, from chemical signals to images of alien ecosystems, from the unknown to the known, and yet never fully. Each trench, ridge, and vent tells a story of geological history, of life's persistence, of Earth's ceaseless transformation. The deeper we look, the more the ocean asserts its autonomy, reminding us that human perception is only a thin veneer over the profound complexity of our planet. In this unmapped expanse, mysteries accumulate like sediment layers, silent yet insistent, awaiting the next ascent, the next probe, the next patient and daring mind willing to follow the echoes into darkness. Even now, as satellites map subtle contours and submersibles traverse previously unseen valleys, the abyss resists full comprehension. Over 80% of its surface remains an uncharted wilderness, a reminder that Earth still contains vast domains where light does not reach, where pressures crush the unadapted, and where life may exist in forms yet unimagined. Each new expedition is a conversation with the unknown, a dialogue with forces older than civilization, and a meditation on the resilience of both life and human curiosity. The abyss, in its quiet immensity, asks us not only to observe, but to imagine, to wonder, and to reflect on our place in the living, breathing planet that we inhabit, a planet whose hidden landscapes are as alien and compelling as the world's orbiting distant stars. Long before humans possessed the instruments to measure, map, or descend into the ocean, the sea was already a universe of its own, imagined and feared, revered and misunderstood. Across cultures and centuries, the deep waters inspired both awe and terror. Ancient mariners spoke of leviathans, titanic serpents coiled in unseen trenches, whose awakening could swallow entire fleets. The kraken, a monstrous creature of ink-black limbs and fathomless hunger, was said to emerge from the shadows to drag sailors into eternal darkness. And Poseidon, the god of the sea, reigned over these waters with capricious wrath, shaping storms and tides as instruments of divine judgment. These myths were more than stories. They were humanity's first attempts to grapple with the incomprehensible, to impose narrative on the vast, silent, and unknowable world beneath the waves. For early civilizations, the ocean was a realm of chaos, a mirror of the cosmos itself. Its surface reflected the sky, yet below lay a realm unlit by sun or moon, an abyss that was simultaneously protective and threatening. To venture into it was to enter a world where the familiar laws of survival no longer seemed to hold. Sailors told of whirlpools that could swallow ships whole, of waters so deep that no bottom could ever be touched, and of glowing lights under the waves, omens or spirits of the drowned. The ocean was death made liquid, a darkness eternal, and yet it was also a place of sustenance, of trade, and of passage. Its duality mirrored humanity's own fascination with life and mortality, chaos and order, the known and the unknowable. Even as tales of monsters and divine wrath circulated, practical knowledge of the sea was slowly developing. Mariners learned to read currents and winds, to navigate by the stars, and to respect the capriciousness of tides. But the abyss remained a blank canvas on which imagination roamed free. A fisherman's catch could become a mermaid, a shipwreck, a testament to the sea's wrath. These symbolic interpretations framed the ocean as a liminal space, a threshold between the familiar human world and a deeper, alien reality. In this sense, the deep sea was humanity's first encounter with the idea of an environment that exists independently of human comprehension, a mirror of the mysteries that would later be revealed through science. Ancient myths often attributed intentionality to the deep. The Leviathan was not merely a creature. It was an embodiment of the sea's unpredictable force. Kraken became a cautionary tale, warning sailors of overconfidence and hubris. Poseidon's trident could split continents in mythic imagination, reflecting humanity's awareness that the ocean shaped life in ways beyond control. Even sea dragons, emerging in folklore from Asia to Europe, suggested that human cultures instinctively understood the ocean as a living, reactive system, dangerous, generative, and profoundly mysterious. These stories encoded practical wisdom in allegory. Respect the sea, fear its depths, and recognize that life above water depends on understanding the balance below it. The ocean's symbolic resonance extended beyond danger. In the myths of many cultures, the abyss represented a source of creation as much as destruction. It was the womb of life, the primordial soup from which humans, gods, and creatures emerged. In Mesopotamian epics, Tiamat's waters birthed chaos and cosmos alike. In Greek cosmology, the depths were realms of unseen forces, home to gods, spirits, and titanic beings that shaped the surface world in unseen ways. The abyss was at once death, mystery, and genesis, a realm of extremes that reflected the extremes of human imagination, fear, and wonder. Sailors' tales also introduced a sense of bottomlessness, a perception of infinite depth. Ships crossing uncharted waters reported echoes of voices, strange lights, and phenomena that defied explanation. Depth sounded with ropes and lead weights often yielded results that confounded expectations. Waters so deep that no instrument could reach the floor, regions of unusual temperature or color, and currents moving in directions invisible from the surface. Even without scientific understanding, these observations nurtured a sense that the ocean was not merely empty space beneath waves, but a structured yet unknowable cosmos, a subterranean universe teeming with its own rules. Early symbolic views of the deep imagined it as a mirror of the cosmos, a reflection of the sky's mysteries within Earth itself. The unplumbed depths were as alien and vast as the heavens above. Stars guided sailors on the surface. Yet below lay constellations of creatures, structures, and phenomena entirely beyond human perception. This parallel between ocean and cosmos shaped the way humans conceptualized the unknown. Both realms were vast, largely invisible, and governed by forces that could be measured only imperfectly, anticipated only speculatively. The abyss was simultaneously terrifying and awe-inspiring, a reminder that humanity exists at the intersection of knowledge and imagination, between the seen and the hidden. Even in this early era, the ocean's mysteries provoked philosophical reflection. It was not merely the fear of drowning or storm that impressed itself upon the human mind, but the recognition that life itself is sustained above a world too vast to comprehend. Sailors understood that beneath their feet lay pressures and ecosystems beyond their reach, that the abyss was a silent, indifferent theater in which their lives were but brief and fragile performances. This awareness, encoded in myth, folklore, and legend, prepared the human imagination for the later revelations of scientific discovery. The abyss was not an empty void. It was a living, breathing enigma, patiently waiting to be measured, observed, and understood. In many ways, these myths laid the foundation for the scientific pursuit that would follow. The leviathans, the krakens, and the sea dragons were placeholders for unknown species. The impenetrable darkness and bottomless depths hinted at the complexity of ecosystems yet to be discovered. Humanity's fascination with these stories was, in essence, a prelude to modern oceanography, an acknowledgement that beneath the surface lies a world shaped by forces both grand and subtle, inhabited by life forms as strange and wondrous as any imagined by myth. Thus, the first relationship between humanity and the abyss was one of narrative, of story, and of symbolism. The ocean was not merely water. It was a living mirror, a reflection of the unknown cosmos, and a canvas upon which human curiosity and fear painted their earliest visions of alien worlds. In myth, the deep was both adversary and teacher, a realm that demanded respect, caution, and imagination. And as humanity progressed from legend to observation, these early interpretations would inform the scientific inquiries that would finally pierce the darkness, revealing a living, alien world beneath the waves, a world as mysterious, vast, and compelling as the myths that first called it into human consciousness. In this sense, the myths of the deep were not simply stories of fear and fantasy. They were the earliest navigation tools for the human mind, offering frameworks to conceptualize the incomprehensible, to anticipate the extraordinary, and to prepare for the truths that lay hidden in darkness. The Leviathan, the Kraken, and the abyss itself became archetypes of the unknown, teaching humanity that the universe beneath the waves, like the universe beyond the stars, demands both humility and wonder. Even now, as advanced submersibles, sonar arrays, and satellite mapping illuminate portions of the ocean floor, the echo of these myths remains. They remind us that exploration is as much about imagination as instrumentation, and that every mapped trench, every photographed vent, every discovered species is a story once told in legend, now translated into the language of science. In the abyss, the ancient and the modern converge. Myth becomes observation, fear becomes fascination, and the human imagination meets the infinite complexity of a world that has always existed beneath the waves, waiting silently for discovery. For centuries, the ocean was a veil, opaque, indifferent, and unyielding. Early explorers and natural philosophers had only rudimentary means to measure its depths, relying on sounding lines, ropes weighted with lead, lowered into the water in the hope of touching a bottom that often remained elusive. Each attempt was an act of faith, a dialogue with a vast, silent unknown. The lines would descend, sometimes hundreds of meters, sometimes thousands, only to return with little more than a smear of mud, a few trapped organisms, or the realization that the ocean was far deeper than any human mind had imagined. These first probes were primitive, yet they hinted at the immensity below, an abyss that stretched beyond comprehension, a darkness so complete that human perception could scarcely grasp its scale. As navigators and scientists gradually compiled these measurements, a startling realization emerged. The ocean was not uniform. It was sculpted with ridges, valleys, and trenches deeper than the tallest mountains. The Mariana Trench, for example, would eventually be measured at nearly 11 kilometers below the surface, a depth so vast that if Mount Everest were placed at its floor, its peak would remain submerged beneath a kilometer of water. The abyss was no empty void. It was a complex, layered realm, shaped by tectonics and currents, its architecture hidden in a perpetual shadow. The human imagination had assumed the deep to be a desolate plain, a bottomless expanse of water. Yet reality proved far stranger and more intricate. The first systematic attempt to explore and understand this alien landscape came with the HMS Challenger expedition, launched in 1872. Over the course of 4 years and more than 68,000 nautical miles, the Challenger traversed the oceans, not as conqueror, but as careful observer. Its scientists recorded temperatures, currents, and depths, while dredges scraped the floor of the sea to bring up sediments, rocks, and organisms previously unknown to science. Each haul was a revelation. Strange starfish clinging to mud, brittle sponges thriving in the cold darkness, tiny crustaceans adapted to extreme pressure, and other creatures so alien in form that their existence challenged everything biologists thought they knew. The Challenger was the first to show that life not only existed in the deep, it thrived there in defiance of centuries of assumption. The expedition's discoveries overturned long-held paradigms. For generations, scientists had assumed the abyss to be lifeless, a sterile graveyard beneath the sunlit surface. Photosynthesis, powered by sunlight, was thought essential for sustaining life. Without light, survival seemed impossible. Yet the dredges of the Challenger revealed a different truth. Organisms could persist in complete darkness, supported by mechanisms as mysterious to 19th century science as the ocean itself. The discovery of life at depth was more than biological. It was philosophical. It suggested that life is far more resilient, adaptable, and inventive than the human mind had previously allowed itself to imagine. The deep sea became not merely a frontier of geography, but a frontier of possibility. Primitive instruments, sounding lines, thermometers, nets, and dredges were the keys that first unlocked this world. Though crude by modern standards, they allowed humans to probe pressures and temperatures unimaginable on land, and to gather evidence that life could exist under crushing weight in near-freezing conditions. Each sample brought back was a message from the abyss, a fragment of a living ecosystem hidden in darkness. Scientists were confronted with creatures that bore translucent bodies, elongated limbs, and appendages that seemed almost liquid in form. Forms shaped by extremes that defy surface logic. Even the simplest organisms hinted at complexity beyond comprehension. Bacteria clinging to rocks, feeding on minerals, tiny invertebrates navigating chemical gradients. Life sculpted by conditions wholly unlike those of the sunlit world. Above, the birth of oceanography was as much an intellectual revolution as it was an empirical one. The ocean had always existed, vast and unknowable, yet required human curiosity, courage, and patience to reveal it. The Challenger and subsequent expeditions transformed the abyss from myth into a subject of rigorous inquiry, from a realm of speculation into a laboratory for understanding life and planet. The sea floor was mapped, not fully, but enough to suggest astonishing diversity of terrain, of chemistry, of organisms. Trenches, ridges, plains, and volcanic outcrops emerged from the unknown, and with them came the realization that Earth's oceans were as dynamic and intricate as its continents, yet hidden beneath a curtain of water that filtered sunlight and muffled sound. These early probes also revealed the ocean as a living system, intimately connected with geology and chemistry. Sediments carried records of ancient climates. Deep currents regulated temperature across continents, and even the faint chemical signals detected at depth hinted at ecosystems structured by forces both terrestrial and planetary. The abyss was not merely a collection of trenches and plains. It was a network of interactions, a world where life and matter danced in rhythms invisible from a surface. In this realization, the deep sea became an arena of intellectual and existential reflection, a reminder of humanity's fragility, the limits of perception, and the astonishing adaptability of life. The scientific birth of oceanography marked a turning point not only in understanding the oceans, but in expanding the human conception of life itself. No longer could biology, ecology, or planetary science be confined to the surface world. The deep sea demanded new frameworks, new theories, and new instruments capable of withstanding pressures that would crush unprotected flesh. It demanded imagination, rigor, and the willingness to confront the unfamiliar. Each sounding line, each dredge, each careful recording was a step into a universe that existed alongside human experience, yet obeyed rules largely independent of it. Even as the Challenger returned home, laden with specimens, maps, and observations, the abyss remained largely unknown. Its mysteries had only begun to surface. Yet the expedition had accomplished something profound. It had transformed the deep from a domain of myth and fear into a frontier of knowledge, laying the groundwork for future generations to probe further. The ocean was no longer an empty void. It was a living, breathing world, vast beyond measure, filled with life both delicate and astonishingly robust, a hidden cosmos beneath the waves. The legacy of these first probes is enduring. Today, submarines, ROVs, and satellite mapping continue the work begun with ropes, lead weights, and dredges. Yet the philosophical impact remains unchanged. The abyss challenges assumptions, stretches imagination, and reminds humanity of the tenuousness of knowledge in the face of the vast, dark, and largely unexplored. It asks a fundamental question that persists to this day. If life can endure where light cannot reach, where pressure would crush, and where temperatures plunge near freezing, what other possibilities exist beyond our immediate perception, in the oceans, on our planet, or across the universe? The first probes into darkness revealed more than biology or topography. They revealed a profound truth about exploration itself. To know the world, one must descend into its unknowns, confront its extremes, and allow observations to overturn assumptions. The abyss became both teacher and challenge, a reminder that curiosity is a bridge between myth and knowledge, that patience and courage can illuminate realms once imagined only in legend. The ocean, in its early scientific awakening, became a mirror of the human desire to see beyond the visible, to understand the invisible, and to recognize that even on a planet we call home, vast and alien worlds await discovery beneath the surface. In the end, the birth of oceanography was a birth of perspective. Humanity had glimpsed the depth, the darkness, and the resilience of life, and in doing so, began a journey that would extend far beyond the Challenger, beyond sounding lines and dredges, into submersibles, satellites, and robotic explorers. The abyss, once a place of mystery and fear, became a frontier not only of the natural world but of human imagination, a stage on which science and curiosity could illuminate the hidden poetry of the Earth itself. The first probes were tentative, fragile, and incomplete, yet they opened the door to one of the most profound and ongoing discoveries of our species, that beneath the waves lies a living cosmos, vast, complex, and endlessly compelling. For much of the 19th century, the deep ocean was imagined as a barren, unchanging desert. Scientific doctrine, shaped by centuries of observation limited to surface waters and coastal regions, assumed that life required sunlight, warmth, and oxygen-rich environments to persist. Beyond a few hundred meters, darkness reigned, pressure intensified, and temperatures fell to near freezing. To early oceanographers, it seemed self-evident. The abyss could support little or nothing. Its vast reaches were presumed sterile, a shadowy expanse devoid of life, a dead zone where Earth's processes continued, but its vitality did not. The notion was elegant in its simplicity, comforting in its predictability. Yet nature has a way of shattering assumptions. As expeditions like the HMS Challenger navigated the oceans, dragging dredges and nets across the seafloor, the first hints of contradiction emerged. At first, the finds were almost laughably small, tiny, fragile organisms clinging to rocks, microscopic creatures suspended in the sediment. They were anomalies, considered curiosities rather than evidence of a new paradigm. But as collections grew, the patterns became impossible to ignore. Strange starfish, brittle sponges, translucent crustaceans, and worms appeared at depths previously thought inhospitable. Some exhibited bioluminescence, glowing faintly in the eternal darkness, as if nature had invented light itself where none existed. Each discovery challenged the prevailing worldview, suggesting that life was far more tenacious and inventive than science had imagined. The collapse of the lifeless assumption became undeniable in the 1870s and 1880s. Every dredge, every sounding line, every meticulous recording brought evidence that contradicted the orthodox view. Life persisted in crushing pressure, in near-freezing temperatures, in darkness deeper than any human had ever descended. The ocean floor, once thought inert, teemed with forms adapted to extremes, species that did not rely on sunlight, that subsisted through chemical energy or specialized predation, that had evolved in isolation from the surface world for eons. The abyss was no longer a void. It was a hidden ecosystem, intricate and self-sustaining, its rules unfamiliar to biologists of the surface. This paradigm collapse was not merely scientific, it was psychological. Humanity's conception of life itself was challenged. If organisms could survive in perpetual darkness, nourished by chemical gradients rather than photons, then the assumptions about the necessity of sun, warmth, and familiar conditions were incomplete. The discovery forced a reevaluation not only of oceanic life, but of life's potential throughout the universe. The abyss became a proof of principle, that life is resilient, adaptive, and capable of thriving in conditions once deemed impossible. Hydrothermal vents, discovered nearly a century later, would extend this revelation further, demonstrating entire ecosystems powered by chemical energy alone, independent of sunlight, dependent on the heat and minerals seeping from the Earth's crust. The early findings of the Challenger and other dredging expeditions were the first tremors of this intellectual revolution. Starfish and brittle stars, small crustaceans, and strange worms seemed almost whimsical in their adaptations. Appendages extended to sense the faintest currents, eyes absent in the deepest specimens, bodies translucent or armored against pressure. Each organism was a miniature miracle, a testament to the inventiveness of evolution under extreme conditions. Biologists struggled to explain how these creatures subsisted. The conventional food chain made no sense. Energy did not arrive from the sun, but from the complex interplay of detritus, microbial activity, and chemical processes at the seafloor. By the early 20th century, the psychological shock extended beyond biology. Philosophers and scientists began to speculate. If life could survive in the darkness of Earth's oceans, why could it not exist in the subsurface oceans of icy moons? Why could it not cling to hydrothermal vents on alien worlds, nourished by chemical energy rather than sunlight? The deep sea became a mirror for the cosmos, suggesting that life is not constrained to the surface or to the conditions humans once assumed essential. Each translucent crustacean, each glowing worm, was a hint at universality, a message from the abyss that the universe may be more hospitable than previously imagined, yet in ways we cannot predict. The collapse of the lifeless assumption also reshaped the methods of oceanography itself. Scientists realized that to understand the abyss, new technologies and approaches were required. Simple sounding lines and dredges could hint at life's presence, but only direct observation and sophisticated sampling could reveal its true richness. Submersibles, remotely operated vehicles, and deep-sea cameras became indispensable, translating the abstract into the tangible. Sonar revealed topography, but only careful descents into the darkness allowed humans to witness the strange forms, the bioluminescent displays, the chemical interactions, and the ecosystems that had persisted unnoticed for millennia. Even as the lifeless assumption crumbled, the abyss remained a frontier of uncertainty. Each new find raised further questions. How do these organisms reproduce in isolation? How do energy and nutrients flow through communities so removed from sunlight? What extremophiles exist in regions untouched by human exploration, in trenches deeper than 11 kilometers, in brine pools, methane seeps, or hydrothermal fields yet unobserved? The collapse of one assumption revealed the vast scale of what remained unknown, the abyss expanding not only in depth, but in conceptual mystery. Ultimately, the realization that the deep ocean teems with life reshaped humanity's perception of its own planet. The abyss, once imagined as a lifeless void, emerged as a living, breathing frontier, as alien and compelling as the surface of distant worlds. It forced reflection on the adaptability of life, the resilience of evolution, and the limitations of human preconception. In the darkness, creatures thrive that would be unthinkable on land, sculpted by forces that challenge the imagination. In doing so, the deep sea became a symbol of possibility, a reminder that nature's creativity exceeds human expectation and that the universe itself may hold many hidden, unimagined worlds where life persists in forms we cannot yet envision. The collapse of the lifeless assumption was thus both a scientific and a philosophical watershed. It affirmed the audacity of curiosity, the necessity of exploration, and the humility required in the face of unknown extremes. Humanity had glimpsed a world previously thought impossible, a realm where life flourishes beyond the reach of sunlight, where evolution has sculpted the alien yet familiar, and where the abyss itself whispers of universes hidden within worlds. In that revelation lies a quiet, profound lesson. The unknown is not empty, and the act of observing it transforms not only knowledge, but imagination itself. In time, the abyss would reveal more wonders: hydrothermal vents, giant tube worms, and ecosystems entirely independent of solar energy. Yet the psychological shock of the first discoveries, dredged, measured, and documented in meticulous detail, remains enduring. The deep ocean is a proof of life's resilience, an uncharted canvas on which evolution writes stories invisible to the surface, and a reminder that even on Earth, the frontiers of exploration extend into darkness as vast and unknowable as the stars themselves. The lifeless assumption has long since been abandoned, yet its collapse remains instructive. It teaches patience, humility, and reverence for the unfamiliar. It reminds humanity that the universe is rarely as simple as our initial impressions suggest, and that exploration, whether of the oceans or the cosmos, demands courage, curiosity, and a willingness to accept that what we thought impossible may, in fact, be the rule rather than the exception. In the deep sea, life persists against unimaginable odds, resilient and adaptive, glowing in darkness, anchored to the earth itself, and thriving without sunlight. And in witnessing this, humanity is confronted not only with biological marvels, but with philosophical wonder. If life can endure here, in such extremes, what else might exist in the hidden recesses of our planet, or on worlds yet beyond our reach? The abyss, once assumed lifeless, has become a mirror reflecting the boundless potential of life and the endless horizons of discovery. In the remote expanse of the Pacific Ocean, along the jagged scar of the Galapagos Rift, a revelation waited silently, hidden beneath the crushing darkness. It was 1977, and the submersible Alvin descended into a world that had remained untouched for millennia. As the vessel crept along the abyssal plains, cameras and lights piercing the eternal night, explorers witnessed something entirely unexpected: towering plumes of mineral-laden water, black as smoke, spiraling upward from the seafloor. These black smokers, as they were later named, vented scalding water enriched with sulfides and minerals, a chemical furnace in the heart of the ocean's cold darkness. What appeared at first to be geological spectacle soon revealed an even more profound truth. Life thrived here, without sunlight, without photosynthesis, without any connection to the surface world's rhythms. Giant tube worms, their crimson plumes waving like alien banners, clung to the vent chimneys. Clusters of clams and shrimp moved with purpose in the scalding currents. The seafloor was alive, a bustling metropolis sustained not by the light of a star, but by chemical energy extracted from the Earth's crust. Bacteria, invisible yet foundational, performed the unthinkable. They converted hydrogen sulfide and other vent minerals into organic matter, chemosynthesis replacing photosynthesis as the primary engine of life. This discovery overturned centuries of assumptions. Life, it seemed, did not require the sun. Evolution had found a pathway in total darkness, under pressures that would crush conventional organisms, in waters hotter than a human could endure. The hydrothermal vents were ecosystems alien in appearance, yet exquisitely adapted to their extreme environment. Giant tube worms possessed no mouth, no digestive system. Instead, they hosted symbiotic bacteria in their bodies, bacteria that processed the chemicals from the vents into nourishment. Shrimp congregated around the chimneys, harvesting bacteria and small organic particles, their translucent bodies glimmering under the submersible lights. Clams lined the vent peripheries, filtering minerals and hosting microbial partners within. Here, life was simultaneously alien and familiar, a testament to evolution's adaptability, a mirror of possibilities beyond Earth. The implications extended far beyond oceanography. The hydrothermal revelation suggested that life on Earth may have originated not under the warmth of shallow tidal pools, as once theorized, but in the depths, nourished by chemical energy seeping from the primordial crust. The vents were living laboratories, providing a blueprint for how biology might emerge wherever chemical gradients exist, whether in the deep oceans of Earth or the subsurface oceans of moons, such as Europa or Enceladus. The universe seemed suddenly more hospitable, its potential for life broader than imagination had previously allowed. Chemosynthesis, the process discovered here, transformed our understanding of ecosystems. Unlike photosynthesis, which relies on sunlight to energize molecules and produce food chains visible from space, chemosynthesis harnesses the heat and minerals of the Earth itself. Bacteria oxidize hydrogen sulfide, converting inorganic molecules into organic compounds that sustain larger organisms. In the black currents surrounding the vents, life depends not on illumination, but on the gradients of chemistry, the invisible alchemy of matter under pressure and heat. Entire communities rise and fall with the vents' activity, their survival intricately linked to the geological heartbeat of the planet. The visual spectacle of the hydrothermal ecosystems was mesmerizing. Towering tube worms, reaching up to 2 meters in height, formed dense forests around the vents. Their red plumes, filled with hemoglobin-like compounds, facilitated the transport of sulfide and oxygen to their symbiotic bacteria. Swarms of shrimp, transparent yet vividly outlined by internal organs, navigated turbulent flows, while clams and mussels lined rocky outcrops in neat colonies, their shells hosting bacterial symbionts in carefully tuned biological partnerships. These organisms displayed adaptations unlike any surface species: tolerance to extreme temperature fluctuations, resilience under immense pressure, and intricate symbioses that allowed life to flourish in total isolation from sunlight. For the scientific community, Alvin's observations were nothing short of a paradigm shift. The deep ocean, once imagined as a barren expanse, was revealed as a cradle of extraordinary ecosystems. The discovery demanded reconsideration of evolutionary principles, of the conditions necessary for life, and of the very definition of habitable environments. Where biologists once saw scarcity, they now saw abundance. Where they had imagined limits, they found possibilities. The abyss, in its darkness and heat, had become a canvas on which life's ingenuity was painted in bold and unimaginable forms. Beyond biology, The hydrothermal vents highlighted the inseparable connection between geology and life. The vents themselves are expressions of Earth's internal heat, forged at tectonic boundaries where the crust fractures and superheated water escapes from the mantle. Minerals precipitate as the vent fluid meets the near-freezing seawater, constructing chimneys and towers that provide habitat and substrate for complex communities. Life here is not merely a passive occupant. It is entwined with the geological processes that sustain it, an ecosystem tuned to the rhythms of the planet itself. The deep sea was no longer inert. It was alive in ways both chemical and biological, a demonstration that life and Earth are co-creators in the hidden realms of the abyss. The hydrothermal revelation also challenged anthropocentric assumptions about energy and food webs. Human experience teaches that light sustains life, that plants feed herbivores and herbivores feed predators. Yet in these deep ecosystems, the hierarchy is chemical rather than solar, microbial rather than botanical. Bacteria occupy the base of the food chain, converting inorganic molecules into the currency of life. From them rise tube worms, clams, shrimp, and crabs, a web of energy completely independent of the sun, yet vibrant and dynamic, rivaling the productivity of some surface ecosystems. It is a lesson in the adaptability of life, in the diversity of mechanisms through which survival can manifest under extreme conditions. The philosophical implications were equally profound. Hydrothermal vents illustrate that life does not require human idealized conditions to exist. It requires only gradients, energy, and adaptability. The discovery ignited speculation about the universality of life, suggesting that wherever chemical energy and liquid water coexist, life may emerge. The deep oceans of Earth became a laboratory for understanding astrobiology. The potential habitability of icy moons, deep subsurface oceans, and other worlds beyond the solar system. Humanity's conception of life, once narrow and terrestrial, was expanded to include the alien and extreme, grounded in the resilience and creativity of evolution itself. Alvin's descent also emphasized the interplay of exploration, technology, and insight. Without submersibles capable of withstanding the extreme pressure, cameras to illuminate the darkness, and precise instruments to measure chemical fluxes, this revelation would have remained hidden. The vents remind us that understanding the unknown requires not only curiosity, but the courage to descend into extremes, to illuminate the dark, and to let observation guide transformation of thought. The abyss speaks to those who listen with both instruments and imagination, offering knowledge far beyond surface perception. Even now, the ecosystems discovered along the Galapagos Rift continue to evolve and astonish. Microbial mats, vent chimneys, and the dynamic interplay of chemical gradients create a shifting mosaic of habitats. Giant tube worms grow, die, and are replaced. Shrimp swarms fluctuate with vent activity, and clams maintain intricate symbioses with bacteria, demonstrating life's persistent inventiveness. These communities endure not in spite of the darkness, pressure, and heat, but because of it, sculpted by the very extremes that would destroy unadapted organisms. The hydrothermal revelation is more than a scientific story. It is a reflection on possibility. It reminds humanity that life is not confined to our expectations, that ecosystems may thrive in forms, locations, and conditions beyond imagination. It demonstrates that the abyss, though remote and alien, is intimately connected to planetary processes, to the evolution of life, and to the search for life beyond Earth. The vents are both laboratories and classrooms, showing that energy, matter, and adaptation can sustain life in the most unexpected places, and that the universe may be far more hospitable than once believed, if we are willing to look in the right places with the right eyes. Ultimately, the hydrothermal revelation reframes the deep ocean. It is no longer simply a frontier of geography or oceanography. It is a frontier of biology, chemistry, and philosophy. It is a reminder that the known world is only a thin veneer atop vast unknowns, that life can persist and even flourish under conditions far removed from surface norms. Alvin's descent into the Galapagos Rift was not just a journey to the seafloor. It was a journey into the conceptual depths of what life can be, a meditation on resilience, adaptation, and the enduring mystery of Earth's hidden realms. The abyss, illuminated by Alvin's lights and interpreted through the lens of science, speaks in a language older than humanity. Its black smokers, tube worms, shrimp, and clams narrate a story of survival without sunlight, of ecosystems powered by chemical alchemy, and of life's capacity to flourish under extremes once thought prohibitive. This revelation echoes across the oceans and into space, offering both a metaphor and a blueprint. Where there is energy, matter, and liquid water, life may find a way. In the darkness of the deep sea, humanity glimpses both the fragility and the inventiveness of existence, and in doing so, begins to understand that the boundaries of habitability, creativity, and resilience are far broader than we ever imagined. Beneath the vast blue surface of Earth lies a world more mysterious than any desert, mountain, or a jungle above. It is a landscape that covers 70% of the planet, yet for most of human history it remained untouched by maps, hidden by depth and darkness. The ocean floor is not a flat, featureless plain, but a realm of immense drama. Home to mountains taller than Everest, trenches deeper than any canyon on land, and plains so vast they defy the imagination. It is a geography sculpted by forces older than life itself, a canvas painted by the shifting crust of a restless planet. At its heart runs a scar encircling the globe, the Mid-Atlantic Ridge. Here, tectonic plates pull apart, and molten rock wells up from Earth's mantle to create new seafloor. This underwater mountain chain stretches for more than 16,000 kilometers, longer than any range on land. Peaks rise thousands of meters from the abyss, some piercing the surface as volcanic islands. Along its ridges, hydrothermal vents roar with heat and minerals, fueling life where sunlight never reaches. The ridge is both cradle and scar, the restless heartbeat of Earth's geology, revealed only in the last century through instruments that could see through the ocean's veil. Yet if ridges are Earth's birthplaces, trenches are its graves. The Mariana Trench, curving through the western Pacific, plunges nearly 11 kilometers below the surface, so deep that if Mount Everest were dropped into it, the mountain summit would still lie underwater. Here, tectonic plates collide, one force beneath the other into the mantle, recycling crust into Earth's fiery interior. The trench is more than a geological feature. It is an abyssal chasm where pressure exceeds 1,000 times that at the surface, where light has never touched, and where life survives at the edge of endurance. Between these extremes lie the abyssal plains, immense flat expanses of seafloor stretching for thousands of kilometers, covered by layers of fine sediment that drift down through the water column for millions of years. They are among the flattest and most featureless surfaces on the planet. Yet even here, subtle ridges, seamounts, and ancient scars reveal the slow, ceaseless churn of plate tectonics. These plains are Earth's hidden deserts, desolate to human eyes, yet home to strange creatures adapted to the deep, from ghostly sea cucumbers to fragile starfish that drift across their silent expanses. The discovery of this hidden geography is one of the great scientific revolutions of the 20th century. For centuries, sailors assumed the seafloor was largely featureless, an empty void beneath the waves. But the Second World War changed everything. In the 1940s, navies developed sonar to detect submarines. The technology revealed echoes from the seafloor, painting crude profiles of the abyss. For the first time, humanity glimpsed the contours of a hidden world, ridges rising like walls in the dark, trenches plunging into unfathomable depth, plains stretching further than continents. These wartime maps ignited a quiet revolution in geology, ultimately leading to the birth of plate tectonic theory. In the decades that followed, sonar mapping advanced with precision. Multi-beam echo sounders, sweeping wide swaths of the seafloor, revealed details as intricate as the folds of a mountain valley. Volcanic seamounts appeared, thousands of them, scattered like stepping stones across the abyss. Some rose high enough to break the surface, forming islands and atolls. Others remained submerged, hidden peaks that shaped ocean currents and ecosystems far above. The seafloor was no longer unseen. It was revealed as a dynamic landscape, as varied and dramatic as the continents we inhabit. Yet even sonar could not cover the vastness of the oceans completely. A new perspective emerged from space. In the 1990s, satellites equipped with radar altimeters measured subtle variations in sea surface height caused by gravity. Where underwater mountains lay, gravity pulled slightly more strongly, causing the ocean's surface to bulge upward by mere centimeters. Where trenches yawned, the surface dipped. From these delicate measurements, scientists reconstructed global maps of the seafloor, not in fine detail, but in broad strokes sufficient to reveal hidden mountain ranges and deep scars across Earth's watery skin. It was a triumph of technology, a way of mapping the unseen through the ripples it imprinted upon the sea above. Today, the mapping of Earth's oceans has become a planetary mission. The Seabed 2030 project, an international collaboration, aims to chart the entire seafloor with high-resolution sonar by the end of this decade. At present, less than a quarter of the ocean floor is mapped in detail. Vast swaths remain blank, more poorly known than the surface of Mars or the Moon. The ocean floor is humanity's last unmapped continent, a frontier as real as space, yet far closer to home. Each new survey reveals not only geography, but history, the scars of ancient tectonic collisions, the paths of undersea landslides, the imprints of climate change written in sedimentary layers. The significance of this hidden geography extends beyond geology. The contours of the seafloor shape ocean currents, which in turn regulate global climate. Submarine ridges redirect flows of water and heat, influencing weather patterns thousands of kilometers away. Trenches capture sediment, sequestering carbon for millennia. Abyssal plains host fragile ecosystems and mineral deposits critical to Earth's chemistry. To map the seafloor is not merely to understand geography, but to read the operating manual of Earth's climate system, its biological cycles, and its geological evolution. And yet, the mystery endures. For every ridge or trench revealed, countless features remain hidden. Vast stretches of the Pacific remain unmapped in detail. Even the Mariana Trench has only been explored at a handful of points. Unknown seamounts may host ecosystems never seen, while unmapped canyons may conceal records of past climate locked in sediment. The ocean floor remains a reminder that Earth is not fully known, that even in the 21st century, discovery awaits in abundance beneath the waves. Philosophically, the seafloor challenges human perspective. On land, geography is visible and immediate. Mountains inspire awe, valleys guide rivers, deserts stretch beneath the sun. But beneath the ocean, geography is invisible, perceived only through instruments and imagination. It is a reminder that reality is not limited to what eyes can see. Our planet's greatest landscapes lie hidden in darkness, revealed only through echoes, gravity, and persistence. The unseen world shapes the scene, just as the deep currents shape the surface climate, and the hidden tectonics sculpt the continents above. In this sense, the ocean floor is both a scientific frontier and a metaphor. It is a landscape that resists human dominion, that reminds us of the limits of perception, and that invites humility. We inhabit a planet we do not yet fully know. To map the seafloor is not only an act of science, but of self-discovery, to understand the stage upon which life has unfolded for billions of years, to grasp the dynamics that sustain climate, and to imagine the possibilities of life in the darkest corners of Earth. The hidden geography of the ocean is a reminder of scale. Ridges rival the Himalayas, trenches dwarf the Grand Canyon, and plains extend further than any desert. Yet they remain unseen, concealed by a blanket of water that both protects and obscures. Humanity has reached the moon, sent probes to Mars, and glimpsed the edge of the solar system. Yet the majority of its own planet remains unmapped, unexplored, and unvisited. The seafloor is a paradox, at once immense and intimate, alien and profoundly terrestrial, hidden yet fundamental to all life above. As the Seabed 2030 project advances, as sonar beams sweep across unmapped plains, as satellites refine their measurements of subtle sea surface bulges, the Earth's last great frontier slowly comes into focus. Each ridge traced, each trench revealed, each plain mapped adds to a planetary mosaic that has been hidden since the dawn of life. And with each new detail comes a deeper appreciation of the vastness, the mystery, and the interconnectedness of the world we call home. The ocean's hidden geography is more than a map. It is a reminder that beneath the familiar blue surface lies an alien Earth, as dynamic and dramatic as any world beyond. It is a geography that humbles, that inspires, and that invites us to keep exploring, for even here, on our own planet, the age of discovery is not over. The deep ocean is a place of crushing silence, where the weight of the sea presses with forces equal to thousands of elephants upon every square meter. For most of human history, this abyss was beyond reach, a place imagined but never touched. Yet, across the last century, technology has pierced this eternal night. Against the weight of pressure, against the indifference of depth, fragile machines and daring explorers have descended into Earth's deepest realm. The story begins in 1960, with a vessel as improbable as the journey it undertook. The bathyscaphe Trieste, designed by Auguste Piccard, was little more than a floating gasoline tank tethered to a steel sphere. It carried two men, Jacques Piccard, the designer's son, and U.S. Navy Lieutenant Don Walsh, into the Challenger Deep of the Mariana Trench. On January 23rd, they sank for nearly 5 hours into a darkness no human had ever seen. At almost 11 kilometers down, the pressure was over 1,000 times that of the surface. Windows creaked, bolts strained, and the abyss pressed in. Yet they endured, reaching the deepest known point on Earth. For 20 minutes, they stared into a world no one else had touched, a silent plain of silt, disturbed only by the movement of a strange flatfish-like creature in the spotlight's beam. Then they rose again, leaving behind an emptiness that would not be visited for half a century. In the years that followed, exploration shifted from singular descents to sustained inquiry. In 1964, the submersible Alvin was launched. Unlike Trieste, it was not a one-time experiment, but a workhorse of discovery. Alvin descended more than 5,000 times across its career, carrying scientists face-to-face with hydrothermal vents, deep-sea life, and shipwrecks like the Titanic. Its titanium sphere and thick acrylic windows allowed human eyes to witness creatures that glowed like stars in the blackness, and chimneys that poured mineral-rich plumes like undersea volcanoes. With Alvin, the abyss ceased to be a rumor. It became a field of study. Yet the ocean's deepest trenches remained elusive. For decades after Trieste, no one returned to Challenger Deep. The abyss seemed almost forgotten until in 2012, a new descent was attempted. This time, it was not a team of two, but a single man, filmmaker and explorer James Cameron. His submersible, the Deep Sea Challenger, was a vertical capsule of green designed to slice through water like a blade. For 2 hours he fell, alone, into the trench. At the bottom, Cameron spent nearly 3 hours surveying a desolate plain, capturing samples, and filming in high definition the silence of a place no camera had ever seen. It was not a stunt, but a continuation of the quest begun half a century before. Proof that the deepest frontier was not forgotten. But the ocean is too vast, too dangerous, and too deep to be explored by humans alone. The future belongs not only to submersibles carrying people, but to the robotic eyes that go where flesh cannot survive. Remotely operated vehicles, or ROVs, like Jason and Victor 6000, are tethered to ships above by kilometers of cable. Through their mechanical arms, humans manipulate the deep from afar, collecting samples, measuring currents, and filming life in its natural habitat. Their cameras transmit the abyss in real time, making the unknown visible on screens thousands of meters above. Autonomous underwater vehicles, or AUVs, take this one step further. Machines like Nereus and Abyss roam untethered, navigating with sonar and programmed intelligence. They map trenches, scan ridges, and capture images where even cables cannot reach. Nereus once dived into Challenger Deep, an emissary of human curiosity sent alone into crushing darkness. These machines extend human perception, granting vision where eyes would be destroyed and endurance where lungs could never breathe. The challenge they face is immense. At depths of 10 kilometers, pressure reaches 110 megapascals, enough to collapse steel, shatter glass, and obliterate electronics. Every descent is a battle against physics itself. Submersibles are engineered like fortresses, with pressure hulls forged of titanium, windows thick as a man's arm, and electronics sealed within oil-filled compartments to equalize pressure. Even so, failures are constant threats. Nereus was lost in 2014, imploding under the strain of the deep Pacific. Every success is fragile, every glimpse of the abyss hard-won. Yet these voyages are more than technical triumphs. They are philosophical gestures. To descend into the deep ocean is to cross into another world, one as alien as any exoplanet. In its silence, explorers encounter life built on principles unfamiliar to the sunlit Earth. Fish with lanterns on their foreheads, shrimp that farm bacteria on their backs, worms that thrive without mouths or stomachs. Each descent reminds humanity that the rules of survival are broader than once believed, that life adapts in ways imagination struggles to follow. With every probe, the abyss reveals not only its secrets, but its immensity. Less than 1% of the seafloor has been seen directly by human or robotic eyes. For every ridge or vent observed, thousands remain unseen. Each descent, whether by man's submersible or robotic emissary, is a keyhole view into a cathedral of darkness. What lies beyond remains uncharted. These explorations also shape visions of life beyond Earth. The crushing depths of the ocean mirror the hidden seas of icy moons like Europa and Enceladus, where liquid water exists beneath kilometers of ice. The chemosynthetic ecosystems of Earth's hydrothermal vents suggest that life elsewhere might also thrive without sunlight, fueled instead by chemical fire in the dark. Every dive into Earth's abyss is, in part, a rehearsal for journeys to oceans that orbit distant worlds. Still, the human descents matter in a way that machines alone cannot replace. To send eyes into the abyss is to confront it directly, to feel the creak of the hull, the hum of pumps, the weight of the unknown pressing from every side. Machines extend knowledge. Humans transform it into experience. Together, they form a partnership. Fragile bodies daring the depths, resilient machines carrying vision where humans cannot. The ocean remains the last true frontier of exploration on Earth. In its trenches, mountains, and plains lies a geography larger than all the continents combined. Yet still, in the abyss, life takes shapes that defy expectation. Where darkness reigns eternal, where pressure crushes and cold slows every chemical reaction, survival demands invention on a scale unseen in the sunlit world. Here, the familiar rules of biology bend and transform. Evolution, under the weight of kilometers of water, sculpts bodies into living riddles. Creatures that appear more imagined than real, yet exist in vast numbers, hidden from all but the most determined eyes. Among these phantoms of the deep is the anglerfish, a predator as grotesque as it is ingenious. Its massive head bristles with needle-like teeth, curved inward to prevent escape. From its forehead grows a fleshy filament tipped with a bioluminescent lure, a lantern of living tissue glowing in the void. In the endless dark, the light becomes both bait and betrayal. Smaller fish, drawn by the faint glimmer, swim into the cavern of the angler's jaws, only to vanish in a snap. The anglerfish's life cycle adds another layer of strangeness. In many species, the male is a fraction of the female's size, fusing his body into hers like a permanent parasite, reduced to little more than a source of sperm. In this world, survival reshapes even reproduction, creating symbiosis both unsettling and efficient. Deeper still swims the gulper eel, a creature with a body as slender as a whip and a mouth that can open wider than its entire head. Its jaws unhinged to engulf prey nearly its own size, a necessity in a place where meals are rare and unpredictable. Its stomach expands like a balloon to contain the catch, an adaptation to scarcity where every opportunity must be seized. In the black void, the gulper eel's luminous tail glows like a beacon, a silent lure for unsuspecting prey. Then there is the vampire squid, a paradox of menace and fragility. Despite its name, it does not drink blood. Draped in webbed arms lined with spines, it floats with eerie grace, its skin shifting between shades of red and black, as if cloaking itself in shadow. Its defense is not aggression, but illusion. It inverts its body, wrapping its arms around itself, exposing spiny projections while releasing a cloud of glowing bioluminescent particles. To predators, it appears both larger and more threatening than it truly is, a performance of survival honed by millennia in darkness. But in this realm, light itself becomes the dominant language. Bioluminescence, the production of light by living organisms, permeates the abyss. Tiny plankton flash when disturbed, fish flicker signals to potential mates, and predators wield light as weapons of deception. Some creatures glow blue, the most common wavelength in seawater. Others emit greens or reds, rare flashes that pierce the gloom like fire in a cave. To the human eye, the abyss is black. To its inhabitants, it is alive with messages of light, coded signals, courtship dances, territorial warnings, and deadly lures. It is a hidden conversation, a silent symphony invisible to those who do not belong. At the margins of the abyss lie landscapes even stranger, brine pools and methane seeps. Brine pools are lakes within the ocean, dense with salt so concentrated that they form distinct, shimmering boundaries on the seafloor. To cross their surface is to sink into a lethal trap. Most life avoids them. Yet along their rims thrive communities of mussels, shrimp, and worms, nourished by chemosynthetic bacteria. Similarly, methane seeps vent hydrocarbons into the water, sustaining ecosystems independent of sunlight. Here, tube worms extend like living organs from the seafloor, feeding on symbiotic bacteria that convert methane into energy. These communities reveal a truth once unthinkable: that life does not require the sun. It can root itself in chemistry alone, flourishing in places that seem hostile to existence itself. The abyss also exaggerates life scale. In its crushing silence, gigantism becomes a recurring theme. Giant isopods, relatives of the familiar woodlouse, patrol the seafloor, their armored bodies stretching half a meter in length. Amphipods, normally the size of grains, grow into giants over 10 centimeters long. And far beyond, giant squid drift through the deep, their bodies extending to lengths of 12 meters or more, their eyes the size of dinner plates. Among the largest in the animal kingdom, designed to detect the faintest glimmer in eternal dark. These titans of the abyss inspire both awe and unease, reminders that evolution's canvas stretches differently in isolation, painting creatures on a scale that seems otherworldly. Speculation lingers about what else might lurk beyond the reach of cameras and nets. If giant squid exist, could there be larger cephalopods, predators as yet unseen, gliding through trenches untouched by light? Sailors' tales of krakens, once dismissed as myth, found echoes in the discovery of colossal squid, species even larger than their giant cousins, armed with hooks on their tentacles and beaks sharp enough to rend steel. What lies beyond them remains an open question. The ocean is vast, its unexplored regions larger than the surface of Mars. In such immensity, the possibility of undiscovered apex predators is not dismissed, but expected. Even without giants, the diversity already revealed is astonishing. Fish that walk with modified fins across the seafloor. Jellyfish that pulse like cosmic nebulas, trailing bioluminescent tendrils. Transparent creatures that render themselves nearly invisible, leaving only faint outlines when caught in the glow of submersible lights. Each discovery expands the boundaries of the possible, reshaping the understanding of life's resilience. The abyss is not barren. It is vibrant, but in forms alien to surface life. Its inhabitants remind humanity that survival is not a single formula, but a spectrum of strategies, of light and darkness, of gigantism and invisibility, of symbiosis and deception. In their existence lies a profound lesson, that life adapts not only to what is familiar, but to what seems impossible. As exploration deepens, the abyss becomes less a void and more a mirror, reflecting the diversity of life in ways that challenge imagination. Every anglerfish's lure, every shrimp at a brine pool, every giant squid's eye reminds us that the ocean conceals a living library, written in bioluminescence and evolution. And within its pages may lie not just Earth's strangest creatures, but clues to life elsewhere in the cosmos. For if such forms thrive here, in cold, pressure, and darkness, might not stranger forms thrive beneath the frozen oceans of Europa or within the methane lakes of Titan? The strange inhabitants of the abyss do more than survive. They expand the meaning of life itself, stretching its boundaries beyond sunlight, beyond expectation, and perhaps beyond this planet. The ocean is not silent. Beneath its immense surface, beyond the reach of sunlight, sound becomes the dominant force. Where light fails, vibrations carry unbroken, traveling thousands of kilometers through the dense medium of seawater. To the creatures that dwell within it, the ocean is a vast chamber of echoes, a soundscape shaped by tides, tectonics, and the distant songs of life. Yet when humanity finally extended its listening devices into this abyss, it did not encounter only the expected. It heard voices that defied explanation. The first to hear them were not scientists, but militaries. During the Cold War, arrays of hydrophones, underwater microphones, were laid across the seafloor as part of the Sound Surveillance System, or SOSUS. Their purpose was to detect the approach of submarines, steel predators moving in silence beneath the waves. But instead of only mechanical whispers, the networks began capturing something else. Signals from the deep ocean, vast in scale, sometimes subtle, sometimes overwhelming, reverberating through the hydrophone lines like messages from an alien world. Decades later, when portions of the SOSUS system were made available for scientific use, researchers began to catalog these mysteries. Among them, one sound became legendary. In the summer of 1997, hydrophones spread across the Pacific registered a signal so loud it could be triangulated to a source more than 5,000 kilometers away. It rose in pitch, swelling like the call of some immense creature. The sound was named simply the bloop. For years, speculation swirled. Its acoustic signature bore resemblance to biological origins, like the vocalizations of whales, but orders of magnitude stronger. If it were an animal, it would dwarf any known species, a leviathan hidden beneath uncharted waters. Some imagined colossal squids communicating in frequencies never before detected. Others whispered of creatures unknown to science, inhabitants of trenches never touched by light. Yet as studies advanced, the most likely explanation emerged: the fracturing of icebergs, a cry of ice under stress, echoing across the Pacific. And yet, even with this rational anchor, the bloop's legend endured. For to the human ear, it did not sound like ice. It sounded alive. The bloop was not alone. Other sounds captured by hydrophones remained equally haunting. There was upsweep, first detected in 1991, a series of long, drawn-out tonal patterns sweeping upward in frequency, seasonal in appearance, and emanating from a region near the mid-ocean ridges of the Pacific. Its origin remains uncertain. Volcanic activity beneath the seafloor is the leading suspect, yet no eruption has been directly correlated. Then came Julia, recorded in 1999, a mournful, low-frequency moan lasting more than a minute. Its source somewhere in the Southern Ocean. NASA satellites at the same time observed a large iceberg breaking apart, a plausible explanation. But the sound, when replayed, carries an eerie quality that makes the human mind imagine breath, not ice. And there was Slow Down, a signal recorded in 1997, its pitch gradually decreasing over 7 minutes, as though something massive were reducing speed across the abyss. It, too, has been linked to icebergs grinding against the seafloor. Yet the name remains evocative, suggesting something alive altering its pace in the deep. Each of these sounds has drawn both science and speculation. Natural explanations, ice quakes, volcanic tremors, tectonic shifts, can account for most of them. The deep ocean is not a static void, but a dynamic world. The ocean is a mirror, but not merely the sky above. It mirrors the cosmos beyond, a lesson etched in water and stone. On Earth, life thrives in darkness, in crushing pressures, in isolation from sunlight. In the chimneys of hydrothermal vents, communities flourish on chemical fire alone, detached from photosynthesis, defying what once seemed essential to life. These alien-like ecosystems offer more than wonder. They provide a blueprint for habitability elsewhere, a guide to where life might exist beyond Earth. Hydrothermal vents are laboratories of extremity. On the mid-ocean ridges, superheated plumes pour mineral-rich fluids into near-freezing water. Giant tube worms, blind shrimp, and colonies of chemosynthetic bacteria create oases in the pitch-black abyss. Here, life relies on chemical gradients rather than sunlight, harnessing energy from reactions between sulfur, methane, and hydrogen. This metabolic strategy, unthinkable in classical biology, demonstrates that life is adaptable in ways humanity is only beginning to grasp. If life can persist in such conditions on Earth, it invites a startling possibility. Distant oceans may host life in similar fashion. Among the most compelling candidates are the icy moons of our solar system. Europa, orbiting Jupiter, is encased in a thick shell of ice, beneath which lies a global ocean potentially more voluminous than all of Earth's seas combined. Observations from the Hubble Space Telescope hint at plumes erupting through the ice, carrying water, salts, and organic compounds into space, a tantalizing whisper of habitability. Enceladus, a moon of Saturn, presents a similar story. Its south polar region sprays jets of water vapor and ice particles, laden with organic molecules and hydrogen, suggesting that hydrothermal activity beneath its frozen crust could power life. Even Titan, with its lakes of liquid methane and ethane, challenges preconceptions, hinting that alternative chemistries could sustain forms of life utterly unlike those on Earth. NASA's Europa Clipper mission, set to launch in the coming years, will study these plumes, map the moon's ice shell, and probe its hidden ocean. Instruments aboard will measure salinity, temperature, and chemical composition, searching for the signatures of life itself. If the deep ocean on Earth can thrive without sunlight, then Europa's hidden waters, warm from tidal heating and stirred by hydrothermal vents, may host life in a parallel ecosystem. Each mission becomes a continuation of humanity's journey into the abyss, this time beneath alien ice rather than Earth's dark seas. The philosophical resonance is profound. Every discovery in the deep ocean reframes expectations for extraterrestrial habitability. Life is no longer a fragile anomaly, bound to temperate surfaces and sunlight. Instead, it becomes a force that finds a foothold wherever energy flows, wherever chemistry allows persistence. The extremes of Earth's ocean become a message to the universe. Life does not wait for comfort. it adapts, it endures, it explores the margins. In imagining Europa, Enceladus, and Titan, one cannot help but see the abyss reflected back. Each vent, each methane seep, each brine pool on Earth becomes a metaphor for the potential hidden in distant worlds. The abyss is a proof of concept for life's tenacity. Its alien forms, glowing in darkness, its slow and steady metabolism, and its chemical ingenuity remind humanity that biology is not constrained to what is familiar. It is resilient, inventive, and perhaps universal. The deep ocean is, in this sense, a kind of interstellar ambassador. Before spacecraft ever touch Europa's icy surface, the vents of Earth speak silently of possibility. They teach that oceans can exist where sunlight cannot reach, that life can thrive without warmth or light, and that the improbable becomes reality in the crucible of extremes. The abyss is Earth's message to the cosmos, that wherever conditions allow, life will find a way. And so, to gaze into the Mariana Trench, or to peer at a black smoker amid the mid-ocean ridges, is to look both inward and outward. It is to see the potential for life not only beneath the seafloor, but beneath the ice of distant moons. The universe is vast, dark, and cold. Yet if our own planet's hidden oceans can sustain life, the cosmos may be more alive than humanity has dared to imagine. In the end, the abyss is not only a frontier of discovery, it is a bridge. Between Earth and the stars, between chemistry and biology, between the known and the possible. Every plume of warm water rising from a vent, every microbial colony clinging to basalt becomes an echo of what might exist elsewhere. The deep ocean whispers of survival, endurance, and adaptability, principles that may define life throughout the universe. And in listening, humanity is reminded of its own smallness, its own curiosity, and its capacity to imagine life in forms far stranger, more resilient, and more beautiful than ever conceived. The abyss, with its darkness, its pressure, and its chemical fires, is a story of life that reaches outward, from the depths of Earth to the hidden oceans of distant worlds, carrying a singular, enduring message. The universe is full of possibility. Humanity gazes at the stars with reverence and precision, charting galaxies billions of light years away, tracing the arcs of distant quasars, and measuring the faint echoes of the Big Bang itself. Yet beneath our feet lies a frontier even closer, yet far more enigmatic, the deep ocean. It is a paradox of knowledge, that the Milky Way has been mapped in greater detail than the undulating mountains and trenches of Earth's own seabed. The abyss, vast and dark, remains the planet's final frontier, a shadowed mirror reflecting both the world we inhabit and the limits of our understanding. The ocean is memory. Its sediments, laid down over millions of years, record every pulse of climate, every cataclysmic eruption, every migration of life across continents now vanished. In layers of clay, silt, and organic matter, the Earth preserves its autobiography, a chronicle written not in ink, but in mineral and microbe, in the rise and fall of oxygen and carbon, in the remains of creatures long extinct. Each core sample is a page, each chemical fingerprint a sentence, telling stories of ice ages, asteroid impacts, and the slow, relentless drift of tectonic plates. To study the abyss is to read the memoir of the planet, to touch the layers of time itself. Yet the ocean is also future. It regulates climate, cycles carbon, nourishes life above and below the surface, and shields humanity from the extremes of weather. It is a crucible of survival, its currents distributing heat, its depths sequestering greenhouse gases, its hidden microbes performing chemical alchemy that sustains atmospheric balance. Without this vast, unseen machinery, the world as known would collapse. The abyss is both incubator and regulator, silent and invisible, yet intimately tied to every breath drawn on land. The deep sea, in its darkness and pressure, also serves as a metaphor for human curiosity and mortality. To descend into the abyss is to confront limits of body, of technology, and of imagination. Each plunge into blackness is a dialogue with the unknown, a reminder that existence is fragile, yet capable of extraordinary endurance. The alien forms of deep-sea life, translucent fish, bioluminescent swarms, tube worms thriving on chemical fire, echo a resilience that challenges our assumptions about what is necessary to survive, to endure, to persist. Every descent into the deep ocean is thus a journey inward as much as outward. The abyss mirrors the human condition, the desire to explore, the confrontation with the unseen, and the recognition of our fleeting place in a vast, indifferent universe. In the pressures of the Mariana Trench, one feels the weight not only of water, but of time, evolution, and cosmic contingency. In the flickering lights of a hydrothermal vent, life demonstrates ingenuity, persistence, and beauty beyond human design. It is a humbling, almost sacred spectacle, a reminder that mystery and discovery are inseparable. And so the abyss becomes a meditation. To descend is to read Earth's memory, to witness its creativity, and to contemplate its future. To listen to its hidden sounds is to hear a voice older than civilizations, to sense rhythms of life that have persisted far longer than humanity itself. To study its depths is to reflect on mortality, curiosity, and the fleeting nature of human knowledge in the face of time and scale. The ocean's darkness teaches patience, respect, and awe. In this sense, the deep ocean is an inner cosmos, a universe beneath our feet that mirrors the expanse above. It reminds us that exploration is never merely